I would like t- I would like to take this moment to show you the principle of cone of vision and how, for example, this effect applies the digital world of 3D. What you see here for right now is a yellow backdrop with a toaster object on it, and the blue toaster is put into the construction box. And this is a nice orthographic look because you can see all the vertical lines are exactly parallel and all lines that are at an angle are parallel to each other as well. Okay, so let's go into a perspective look. And what I would like to point out to you is pay attention to those corners. You see, they're actually pretty pointy. However, if we go into top view orthographic, you see this is just 90 degrees. But if we go into a perspective look, you can see actually how much they are getting pinched. And for example, if I move this along the y-axis towards me or away from me, you see that right now it really looks like this is pinched and sucked into the left and the right corner. If we, for example, rotate the view a little bit, it starts looking better. So you see that in perspective, everything that's getting very close to the camera will get a much stronger perspective distortion look, and everything, if for example we move away, will not look that bad. So you see if I move out, move out, move out, it gets flatter. If I zoom in and I zoom in and I zoom in, the effect gets really noticeable. And for example, what I'm changing here right now is the so-called station point. So I always get closer and closer and closer to the object. But I have like a 60-degree cone view of everything that I could show inside this cone that will be representable. And you see, in this case here, everything is inside the cone, but here my ground plane is way at the edges of my page. It's way up beyond the cone of vision, so it's totally distorted. And please keep in mind or take a look at those images again I showed inside the architectural and interior photography or rendering, that there were a lot of shots where everything was very close to the camera or to the edges of the wall. Before it shows like drastic distortions, just show the wall and the ceiling and it will be okay. Let me now show you one of the two problems establishing the relationship between size of the object and position of the vanishing points. I'm going to extreme cases. So I set my camera to a lens of 10, which means I will have a really strong perspective distortion. And now you see that this is really extreme. If I go to a ground plane, it doesn't look only that the object moves up, it actually feels like it's moving away from me. And specifically from this view, what we can nicely observe is, check out those lines. So what we see here is actually our object is way too big compared to the size of my drawing. When this is my left and my right vanishing point, my object is not really the required 1/5 maximum of this distance. So my object is too big, my vanishing points are too close to each other, which will make the whole thing feel squeezed this way. So this is a case for drawing when, for example, you put your vanishing points too close to each other. Now let's go into opposite extreme. Let's make this a 200. And let's maybe rotate around a little bit. Let's zoom in. And I have perspective for shortening for sure, but it nearly feels like this is feeling a lot flatter now. So if, for example, I put down some lines, you see actually here in this case, I cannot really find the vanishing points. They will be there somewhere eventually, but the problem is they're pretty far away. And let's say, I don't know if maybe I can find it this way. Let's see. Hold on. Yeah, you see it will be maybe here and one will be maybe there. So this is the opposite case. Your vanishing points are way, way, way too far away from each other and your object is tiny. So in case this would be your page, tiny object, too small, and that will give you this look of your object being squeezed or flat. It has a tunnel look. And that's also, for example, if I go to here, you see this is perspective. So that this is not an orthographic look. And you can clearly see that there is some sort of foreshortening happening. But this part looks actually really tiny, really flat. And if I go into 15 and I zoom in, you see now that this yellow floor actually looks much, much deeper. But it's only an illusion because it didn't really change the size, but based on the perspective lens and the perspective distortion I gained, I got different foreshortening effects. And you see that actually also this effect applies to the digital world. So if I want to have something at an extreme lens, kind of like a really wide one, everything around outside I have to clip out, similar like with the photography. If I can't show something, I just leave it out or only show floors, walls, and ceilings without anything on it. And everything I really want to show, I just put at the center of my camera or my picture. So I have perspective foreshortening there, but I don't really have a strong perspective distortion. I hope that this quick interactive demonstration was helpful to you to understand the problem with the vanishing points and the cone of vision and how this applies to your drawing, because again, the way how we perspectively draw to a certain degree is also the way how a software automatically represents 3D information to us. And in the software here, I don't really deal with left and right vanishing points. However, I kind of like also don't really deal with a cone of vision. I just deal with a lens. Unfortunately, I don't really see a cone of vision, which might actually be interesting to see. But then with the lens, I know I go really close, like with a lower number, that's a wide lens, so everything is distorted, or I go really high, everything is going to be flat. And I feel like something like a 55 seems to be, I don't know, maybe comfortable for your eyes, similar to the way how your eyes see it from a certain distance.